ABCD is a parallelogram. Prove that the diagonals of ABCD bisect each other and justify each step. Okay, so this one isn't multiple choice, but I really wanted you to see it. So you're given this proof and you have to do a constructed response. So the way I usually tackle proofs is I usually like to kind of look at the picture and think through and write down just some notes on everything I know about it. So if I was doing this proof before I ever started writing my constructed response, I would look at this and say, okay, I know it's a parallelogram. So I know that the opposite sides are parallel, and I also know that the opposite sides are congruent. So AB is congruent to CD, and I know that AD is congruent to BC. I know that because it's a parallelogram. All right? And then I also know that opposite sides are parallel. So I'm going to go ahead and make my little parallel marks. And again, that's the definition of a parallelogram. The opposite sides have to be parallel. So if we have these two parallel lines, let me highlight them. If I look at this parallel line and this parallel line, it gives me some information about the angles too. Like if I look at this angle right here, its alternate interior angle would be right here. So I know that those have to be congruent. You could say the same thing about a whole bunch more of these. There are lots of alternate interior angles. So we could mark all of them. It might make our picture a little crazy though. So let's go on to what else we know. We also know vertical angles are congruent. So we know that this angle has to be congruent to this angle. Okay, there's a lot more that we know, but something kind of stands out in my mind, and you may not see it yet, but I'm going to go ahead and highlight it so that you can see it. If I look at this triangle, ABE and this triangle, and I just look at the markings I've already done, I have a side marking, an angle marking, and another angle marking. Excuse me. So remember, you can write that as angle, angle, side, or side, angle, angle. The order doesn't really matter. But then you look down here and you have the same thing. You have your side, your angle, and your angle. So these two green triangles are congruent. All right? So what we know, the reason why that's important is if the two triangles are congruent, we know all of their corresponding parts are also congruent. So I now know that AE has to be congruent to EC because of congruent triangles. Same thing here. I know that DE has to be congruent to EB because corresponding parts of congruent triangles are congruent. And if I know that the two pieces are congruent, then I know that they bisect each other because that's the definition of bisecting. Okay, so that is how you're going to walk through this proof, and that is just some chicken scratch kind of thinking through it. And now we want to look at what they're actually looking for in the responses. So I want to start down here at the bottom. You will only get 1 point if you say this. Angle ABE is congruent to angle CDE, and angle BAE is congruent to angle CDE because they are alternate interior angles. Side AB and DC are congruent. Line segment AE is equal to CE, and BE is equal to DE. By definition, AC and DC must bisect each other. So here's what stands out in my mind. Everything that they have written is correct, but they only get 1 point for that. And let's think about the reason why they're only getting 1 point. They're not giving justifications or details. Let's look at this. It says sides AB and DC are congruent, but they never tell us why. They never say because it's a parallelogram, and by definition of a parallelogram, the opposite sides have to be congruent. They say line segment AE is equal to CE and BE is equal to ED, but they don't tell us why. They don't say corresponding parts of congruent triangles are congruent. So everything they've said is correct, but y'all, when you do constructed response, you need to put as many details as possible. So now let's skip and let's read the 4-pointer. This would be maximum credit. Line AB and CD are parallel, making angle ABE congruent to angle CDE, and angle BAE congruent to angle DCE because they are alternate interior angles. So again, lots of information here. They supported it with parallel lines and alternate interior angles. Then they said side AB and DC are congruent because opposite sides of a parallelogram are congruent. Again, they're saying the same thing they said below. They're just giving the justification for it. So this makes triangle ABE congruent to triangle CDE by angle, angle, side. Down here in the one-pointer explanation, they didn't tell how they knew those two triangles were congruent. So it's really important that you say that and you give your justification. And then segment AE is equal to CE and BE is equal to DE. So by definition, AC and BD bisect each other. All right, so I just wanted to point out when you get to that constructed response, I use scratch paper first and I kind of look at my picture and I just put as many things as I know on my picture until I know which direction I'm heading with my proof. And then when you go to actually write your constructed response, give as many details as possible. Make sure you justify each and every step.